Welcome to the course Business Analytics and Data Mining Modeling using R Part 2. So, in previous few lectures we have been discussing association rules. So, let us do a small review of what we have discussed so far. So, we started with our discussion on association rules, what it is about, the different names for this like FNT analysis, market basket analysis. We also talked about the main idea is to find to identify item associations in transaction type databases and formulate probabilistic association rules for the same. So, what goes with what? If a particular, so typically the examples that we have been taking are in the a marketing domain. For when the customer is going for a purchase in a supermarket or retail store, if a particular item X is being purchased, then what else is also being purchased along with that item. So, what goes with what kind of analysis we typically do in association rules. So, all these things we have talked about. So, we talked about the if then statements that are typically used in association rules. We talked about two stage process. So, first stage being rule generation, where we apply a priori algorithm. So, we had discussed a priori algorithm in previous lecture. We also talked about the rules that are generated in the first stage, how the strength of those rules are assessed, so that we can select the most important rules for implementation. So, these things have been discussed so far. We have also taken one example for mobile phone cover. We discussed two transaction data formats in the last lecture, item list format and binary matrix format. So, those things were also covered. So, antecedent, consequent item sets and the concept related to these these item sets we have discussed in previous lectures. We also talked about the frequent item set. After that previous lectures we have also discussed a priori algorithm, the different steps for it. For example, first we start with the generation of frequent item sets having just single item. Then this particular list of frequent item set with single item is taken for generating frequent item sets with 2 items and so on so forth, frequent item sets with 3 items, frequent item sets with 4 items. So, in this fashion we keep on going. We also did a small generalization, where we say that to generate k item sets we use frequent k minus 1 item sets. We also talked about the priori algorithm and the lower computational intensity that is required, because of in each step we just need to go through once through the database. So, all those things we have discussed so far. We talked about a few metrics for assessing rule strength. So, in terms of rule generation we talked about support and its importance in generating rules. Then we talked about these two metrics, confidence and lift ratio, which could be used to assess the strength of association rules. So, we discussed and defined these two metrics in previous lectures, confidence and lift ratio. So, we then thought of support and confidence metrics in probability terms. So, this part we were able to discuss that confidence can be defined as the conditional probability of occurrence of consequent item set, given that antecedent item set has occurred. So, these things we were able to discuss. Then while our discussion on lift ratio, we talked about the benchmark value, the benchmark confidence value, and its importance, how it is calculated. So, we discussed how the expressions for benchmark confidence can be can be defined. So, we discussed in the previous lecture that benchmark confidence value can be determined as the probability of occurrence of consequent item set. So, those formulas were also discussed. We defined lift ratio. We also talked about the usefulness of a rule using lift ratio value. So, it should be greater than 1. So, for any association rule to be useful, it should be the lift ratio value should be greater than 1. In exercise in our studio environment, we also went through some of the examples where we saw how the rules can be generated and then how we can assess the strength of the rules. We sorted the list in particular lift ratio order. All the rules were sorted using lift ratio order. So, all those things we did. As I talked about transaction data format, item list format, and binary matrix format. So, these things we discussed in previous lectures. We also talked about the results interpretation part and how importance of support, confidence, and lift value. We talked about that higher value of support and confidence value and lift ratio are desired for selection of top association rules and later on implementation. So, then we also talked about the statistical significance of these rules, the chance occurrence. So, we did an exercise where data was randomly generated and then association rule binding was applied, and we found that even with the randomly generated data we are able to find some strong association rules. So, what about the significance, whether these rules can be taken as at face value or whether we should look for something more. So, we discussed a few rules of thumbs, few points that could be considered, for example, more number of transactions for a rule, and if there are more number of distinct rules, then chance of spuriousness is going to increase. So, all those things we talked about. Before we move on to further comments on association rules, we talked about that one exercise that we are going to do using a particular data set. This data set is also manufactured, but it is based on a more real life like situation. So, we will go back to our studio and we will go through this particular example. We will apply association rules and whatever concepts and exercises that we have done in previous lecture, we will try to repeat that and discuss in more detail. So, let us scroll through the part which we want to cover. So, let us load the this library. So, A rules is the package that we require to develop our models to do our association rules mining in our environment. So, once this is done, we will move forward. So, in the previous lecture we were trying to load another library. So, we were facing some problems in installing that particular package. So, this one. So, the problem that we faced was that Java was not installed in this particular system, and that is why that our Java library, though we were able to install it, we were not able to load it into our studio environment. So, since now we have already installed Java in this particular system, now we should be able to load this particular library. As you can see, in this session we are able to load this library. Now, we talked about this Georgia Cafe data set. So, let us import this data set into our environment. So, let us run this code. So, we have talked about this particular piece of code in a previous course on business analytics and data mining modeling using R. So, for more detail about these functions and how we are using them here, you can always find in those video lectures. Of course, you have the advantage of help section here in this R Studio environment, and you can always look for the manuals for these functions, read.xlsx or any other functions that we are using. So, let us run this code and import this particular data. So, we can see here Georgia Cafe, this one. So, you can see in the environment section this particular file has been imported into our environment, and you can see 148 observations of 9 variables. So, now let us remove any any redundant columns here. So let us run this code. And now let us take a backup of this data set that we have just imported. So in case if we plan to do some modification and transformation in some of the variables, then it is always recommended to take a backup before proceeding with those transformations. So now the next code is about the few observations. So let us look at these first few 11 observations of this data set. So as you can see here, first column is transaction number. So this particular data set is about this Georgia cafe, where customers can buy different snacks and beverage items. As you can see in the columns itself, tea, coffee, frappe, patties, samosa, soft drinks, burgers and chips. So these are some of the items that are being sold by this cafe, and different customers they have purchased different items. So those transactions along with their transaction number, transaction IDs have been recorded. So each row is representing a transaction. So for example, first row is transaction number 561 and the items that they have purchased. So you can see they have purchased just the one item, that is chips, one packet of it. And the numbers that you see in this particular data set, they are representing the number of units that they have purchased, right. So but however, typically what we require is just the presence or absence of that item. So later on, as we will see that we would be converting this particular data set into a format of ones and zeros, where 1 would be representing whether that item was part of that transaction or not, and 0 would be absence of it, and 1 would be presence of it. Right now these numbers that you see 3, 2, 1 or 0, they are representing the number of these items that have been purchased. So this also has the information whether they have been purchased or not. Let us look at the structure of this particular data set, all the variables that are part of this data frame. So if we look at this particular data frame, as I talked about, 148 observations, 9 variables. You can see transaction ID, tea, coffee. So because all these are number of units that have been purchased, so you can see all these variables are numericals. So we are not required to do any transformation as such here, because as I talked about, we would just be requiring ones and zeros. So right now this particular data set, as you can see, is in the numerical format. Now we can use the apply function to convert all these values into the logical format. So the values would be true and false. So more detail about this particular function apply you can find out in the help section. So you can see the first argument is the data frame on which we want to apply this particular function. Third argument is the name of the function that we want to apply on the first argument, that is the data frame. So as dot logical, so this function would actually coerce the points into logical variables, and you can see the second argument is talking about 1 and 2, 1 representing rows and 2 representing columns. That means all the cells on all the cells this particular function is going to be applied. So let us go through this. We are doing this because we are interested in just the presence or absence of a particular item in a particular transaction. So let us run this and let us look at the first 6 observations here. Now you can see we have just the items that are available. So all the items are distinct, 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 items, 8 distinct items, and whether they are present in a particular transaction or absent, that is being represented using these values, true or false. Now we can always convert this particular data frame into transactions format. So for this we can use as a function. So let us run this and we will get to convert this particular data set into transactions format. Now this is done. We can look at the summary of this. So you can see here, So, few details about this particular format is available. You can see most frequent items. You can see tea is the most frequent item, followed by patties, samosa, and all those other things. So, as we talked about in previous lecture, inspect is the function that could be used to look at the transactions database. So, you can see now this format is the item list format, where each transaction is representing the name of the items that is there. So, you can see in this we have just first 6 transactions. So, first transaction is having just chips, second transaction is having coffee and patties, third transaction we have tea, coffee, samosa. So, each of these transactions now what we are seeing right now is the item list format, each transaction having the name of the items. Now, to proceed with our association rules mining, what we will do is we will call this Apriori function, but before calling this function, we need to establish our support level, minimum support level, and minimum confidence level. So, as you can see in the commented line, I have specified support as 20, that is the number of transactions, and the minimum confidence as 50%, that is the percentage minimum accepted confidence value in percentage terms. So, now you can see in the next line I am calling the function Apriori, and I am passing on the first argument this transactions database that we have just created. In the parameter I am specifying the the minimum support level, that is 20 divided by 148, and the confidence value. So, you can see these values are in proportion terms. So, appropriately they have been specified. So, let us call this function. Now, once this is done, we can always sort this particular output of a Apriori function into lift by lift values. So, let us run this next line, and now we can use the inspect function to look at the details of the output. So, now as you can see there are a number of association rules have been displayed in this output, and you can see that all these association rules have been sorted in decreasing order of their lift value. So, the first association rule is having the highest lift value. So, as you can see the lift value is 1.17. So, from this database that we have, Georgia Cafe database that we have, we are not getting many association rules with higher lift values. So, even the top association rules are having lift values around 1. This is only the first transaction is having just a bit higher lift value, that is also not much high, it is just 1.17. So, you can see that in this first transaction we have frappe, and if the frappe is being purchased, then samosa is also being purchased. So, this is the strongest association rule that we have from this database. So, as you can see is frappe and samosa is being purchased. This is not something that we would ideally expect as to be a strong association rule. So, all this is because of the manufacturer data set, and so the real relationships might not anyway be captured. However, for an exercise we can see here other association rules. So, in this you would also see that some association rules are involving the same items. For example, you would see that association rule number 4 and 5, tea, samosa, if tea and samosa are being purchased, then coffee is being purchased. So, the lift value is higher than 1, just above 1, and in the transaction number, in the association rule number 5, you see that if tea and coffee are being purchased, then samosa is also being purchased. So, this is also having a lift value of just above 1. So, you would see that the same items are being used. So this is not unusual. Rather this is more favorable thing, because you will have to deal with, you can have more number of association rules and still deal with the say, fewer number of items. So we can have this kind of situation where the one item set is leading to more than one association rules. So other things also you can look at. So since this output has been sorted using lift value, so strongest association rules will come on top. So in terms of as we talked about in the previous lectures, we should always select the rules which can be reasonably incorporated in human decision making process. So probably if we have to select the rules from this output, the rules which can be implemented for their business and operational applicability, we will have to select few rules from the top, right. So if we look at the some of the rules from the top, then we see that, as we talked about, that we would prefer all these values, support, confidence and lift values, to be on the higher side. So we also talked about that we to avoid spuriousness, to get more meaningful rules, we would like to have support that is count, more number of transactions supporting a particular rule. So we look at the first association rules. The count is 20, however it is having higher lift value, quite good high value of confidence, but slightly lower support. But if we look at the if we look at the transaction association rule number 2, that is, if coffee and samosa are being purchased, then tea is also being purchased. So there we look at that 47 transactions, transactions are supporting this particular rule. So in total we have 148 transactions, and out of that about 31% of the transactions are supporting this rule, and we are also having the second highest lift value. We are also having a very high confidence value. It might be the highest also if we are able to look at the the full table and sort it out in confidence values, and then we can find out. So high confidence value, high support for the second association rules, and of course high count, high lift value, relatively high lift value, and higher confidence and support value. So from this we can see it is the second association rule that we might be willing to invest a bit more, implement. Now if we go down this table, we see that there are few association rules like 6, 7 and 8, 9. So and even if we go down further, we see that support level is increasing around this. So we see that association rule number 14, if samosa is being purchased, then tea is also being purchased, not this one, just above this, tea is being purchased. So you can see most of the transactions involve that tea is being purchased, 116, patties 100 transactions. But if we are not interested in single item association rules, then probably this transaction, if samosa is being purchased, then tea is being purchased, 76 transactions are supporting this association rules. However, lift value is lower, so probably lift value is less than 1. So probably will not go with this. So we will have to stick to the association rules which are having lift value higher than 1. So we take that as the criteria, then we will have to consider the association rules up to 9. So association rules from 1 to 9 are to be considered if we follow this criteria, that lift value has to be higher than 1. And within this, if we see that rule number 6 and 7, they are having the highest support, right. They are having highest count, 71 and 71, and we can see higher confidence value, high support value, higher count, and also the lift value is greater than 1. So probably association rule number 6 and 7, these are the rules that we might be interested into implementing first, right, even though they do not have the highest lift value. So, if we look at these association rules, if coffee is being purchased, then tea is being purchased, and if tea is being purchased, then coffee is being purchased. If we look at these, so they essentially, in terms of implementation, we just get the one decision rule. So, this coffee and tea, they are being purchased together. So, this particular information we can use in our business and operational implementation in our decisions. After this, we can look at the rule number 4 and 5. Rather, we will prefer the rule number 2 for it being having the higher lift value. So, after rule number 6 and 7, we will probably go with rule number 2, that if coffee and samosa are being purchased, then tea is also being purchased. And then after that, if we still are looking for more rules to implement, then probably 4 and 5. However, again you can see 4 and 5 effectively they also converge to the same thing. So, these rules also these rules involve just 3 items: tea, samosa and coffee. So, if we are looking for just top 3 rules that we would like to implement, then the first one would be based on rule number 6 and 7, tea and coffee, that association. Then tea, samosa and coffee, that association would be third. The second one would be coffee, samosa and tea. So, if we look at the rule number 2 is also involving the same item. So, essentially top things that we would like to implement from this output would be, first thing would be tea and coffee, then the second thing would be tea, coffee and samosa. So, based on this output, as you can see, we can restrict ourselves to some fewer number of rules, some few rules which are satisfying all the criteria that we want: higher transaction support, higher number of transactions supporting them, higher support value, higher confidence value and higher lift value. And then some of these rules will involve the same items. So, using all this, we would be able to get some few implementable information, implementable associations between items and move ahead. So, let us move forward. So, some of these rules, as we have seen that some of these rules might be redundant. So, some of these rules might be subset of some other rules. So, how do we eliminate these redundant rules which are subset of some other rule, right? So, we have some code for this. So, you can see we are calling here is dot subset function. So, this function can be used to identify the item sets which are subset of some other set. So, let us run this code. Now, in the next line, as you can see that because we will get a so lower triangle, so lower triangle values and upper triangle value would be same. So, we would like to strike lower triangular using NA values. So, the second line is doing precisely that. So, let us run this. Then as you can see, we are using call sums function. So, it will sum all the subsets or the item sets which are subset of one or more than one set. So, all those item sets would be identified. So, let us run this. So, we can also from here we can also see which of these subsets or which are these item sets are subsets of other item sets. So, we can see a big list is here. So, we can always prune this list, and the remaining we will just have the remaining items which are distinct. So, we run this. Let us look at this. Let us call this inspect. And so, right now probably there was in this particular run there we were not able to find some unique items. So, otherwise we would have got an output where some remaining subset would be there. So, then there is once these remaining rules are there, then we can use this particular library a rules which. So, this is only for visualization purpose. So, the rules they can be a graphic can be created which can convey the information about these shortlisted rules in terms of the different shape of different shapes that are being used, their size of those shapes and color of those shapes can be used to convey different kind of information. So, for this we would be requiring this library. So, let us try and load this. So, this is not installed. So, let us run this. So, we will have we'll try and install this particular library, install.packages. So, within double quotes we will like to enter the name of it. So, once this particular library is installed, and then we can load it, and you will see in this run we have not been able to shortlist rules. We do not have a real output in this particular rules. Otherwise, we would be able to see that shortlisted rule they can be depicted using certain shapes, and size of those shapes and color can convey certain information. Right. So, for example, size can convey the number of transactions that are involved, and the color can convey the lift value. So, support, confidence and lift value can be depicted using some of these graphics and different visualization. So, it essentially it would be a multi-dimensional graphic. So, what we can do is we can do one more run of this particular, we can we can apply association rules one more time, and if some output is after pruning we get a few rules, shortlisted rule, then we can of course visualize them using these functions. So, right now this package is still being installed. So, this is about to be completed. I think this package installation is almost complete. Just about there, the packages are being unpacked and installed. So, it seems to be stuck somewhere. So, as I talked about that once this library is loaded and we have shortlisted some rules, they can be visually seen. The importance of those rules, their strength using different metrics that we have talked about, support, confidence and lift value. So, using shapes and colors we can create a multi-dimensional graphic using this particular code, and we would be able to see it. So, we will stop here, and we will start our discussion on cluster analysis in the next lecture. Thank you.